Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Enhancing OFDM Communication in Wireless Systems Through Tuned Filter Optimization. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the recent research that we are conducting in the domain of wireless communication. So there we are designing some filtered based and equalization based approach in order to provide a better communication among the networks. So let's move to the video. Before starting the video, let's talk about that what we will cover into it. In this video, initially we will talk about in which application areas the design protocol the module can be implemented, where it is useful. Then we will talk about whatever the code we have designed, how to execute, which files are to be executed, what are the software and library requirements for the code. Then we will talk about that what current systems are doing in the same domain, what are the challenges with them, and how proposed work is handling those, and what exactly we have done into the proposed work. Finally, the experimental outcomes and the findings will be discussed. So let's talk about the application areas. So OFDM is basically related to the wireless communication. So in the domain of different areas like wireless LAN, satellite communication, for the OFDM, for the Wi-Fi. So in those such domains where communication is being done using the OFDMs, this system can be implemented. For the WiMAX or the Wi-Fi, which is basically a short range communication system through the wireless modules, there these protocols are very helpful that how data is to be transferred from one location to another. Then in the domain of digital video broadcasting, where the real-time videos is being broadcasting from one place to another without any loss, with a higher quality. So there in that domain the developed system is very much successful. For the digital audio broadcasting, like digital radios or communication by using the audio files, so there this domain is very much helpful. In short, if we will talk about the domains of the developed system, so it is restricted not only to the normal communication, it can be in that certain areas like digital radio manual, then digital video standards in which the digital video broadcasting can be there, wide data transmissions, wireless LANs, which I already told, some cellular data where LTE based systems and 4G cell phones. There are certain confusions that OFDM was only restricted to wireless communication in the initial stages. Currently LTE, 4G, 5Gs are there, so whether it is useful there or not, but it is an integral part of the 5G and cellular deployments, and also the part of the LTE and the 4G cell phone networks, because the OFDM got the variation among the like single band OFDM, and many variants of the OFDMs there. The basic scenario of communication is still same, that how it is transferring data in the wireless. So these are the domain in which the current research can be operated. So now let's talk about the code. So you will get a folder named code like this, under which there are two folders. One is AWGN with WA, second is relay with WA. So let's open any of the folders. So I'm opening with the AWGN. So it is having all the files with them, whatever we have designed for the code. The whole code is implemented in the MATLAB, so you must have the MATLAB software with you. So the MATLAB version that I'm using is 2019. So you can use 2018, 19 or the upper version, but make sure it should be the full version. So in order to run the code, what you need to do, you just need to go to the folder where the code has been placed. As you can see, this is the code folder. You just need to copy the path of the code folder and then go to the MATLAB and paste it here, control V, and press enter. When you will press enter, you can see whatever the files were there in that particular folder, you can get those. So there are two files, one is this and one is this. So we have implemented two of the scenarios in a single section. So ultimately we do have two sections. One is where we are working with the AWG and noise channel, and in second case we are working with the relay fading channel, right? And even in the single case there are further two cases in which only WA is implemented. In second case, WA and ML technique is being implemented, which is equalizing the data. So these are the files that we are using here to run the code. So in order to run the code, you just need to click on the file which you want to run. Then click on the run button here. The editor window is there. You just need to run here. When you will click on the run, it will start executing the part. Now let's talk about that, what exactly we are doing and what is initially happening. In many of the previous scenarios, there are certain applications provided in which the OFDM systems or the variant of the advanced OFDM systems is basically focused on transferring the data and following like reducing the noise, equalizing the channels. This is what they are doing. Very rare studies are available where some additional modules has been implemented to the communication channel in order to reduce the error at the receiver end. So the advancement that we have made into the proposed methodology is like we have designed the whole OFDM system in which initially WOA, that is an optimization algorithm. So let's say what is WOA. So it is a whale optimization algorithm. So this algorithm was proposed in 2016 by using the person named this, so which is not specifically designed for any specific area. This is the nature inspired algorithm in order to achieve any of the solution for any optimization problem. So here optimization problem is to get the coefficients of the filter. So the improvement that we have done to the current OFDM systems in the wireless communication is we have embedded one filtration process in the transmission before the data is getting passed to the receiver. So there the filtration process is filtering by using the digital filter. So digital filter generally focus on the coefficients, the hyperparameters, because hyperparameters are the crucial part for any of the filter to give a better response. So WOA optimization is helping us to tune those hyperparameters of the digital filter applied. Then we are analyzing that what is the impact on the outcomes when this digital filter is applied to the system in comparison to the normal OFDM system with some other advancements. In second of the scenario, what we have done along with the WO based filtration coefficient finding, we are also applying ML. Here I am showing you here MLSE equalizer we are applying to the data, which is expected to equalize the data at the receiver end in order to achieve less error at the receiver end. So these are the two modifications we have done. So the major contribution is the role of WA to find the coefficients of the filter design. Secondly, implementing the MLSE equalizer in order to reduce the error at the receiver end. So both are behaving in managing that data. So let's see that what we have done. So this is the initial factors that we have defined. Even you can change the parameters in order to get the variability among the outcomes. So WA is applied in order to get the best coefficient. Those coefficients has been applied in the filter hyperparameters, which are used later on. Then the signal is being generated and the modulation object is initialized. Here the all parameters for the transmitter have been defined. Then this filtration factors has been applied to the signal that we are transferring. So this transferred data is basically helping us in handling that data. So whatever the data is being transmitted at the receiver, and we are analyzing that how much error is there after the demodulation process, calculating the bit error rate, the inverse of the OFDM system to get the final outcomes. So finally we are evaluating the outcomes in different parameters that includes, so let's talk about the results, that is SNR with respect to bit error rate of two parameters, where normal FBMC method is there, and second is FBMC with the WA method. WA is our approach. So when I'm running this code, I already ran it. So you can see this was the initial k is equal to 4 power spectral density of the transmitted signal. This is the bit error rate received. This is the comparison of the normal and our approach. Here you can see the bit error rate is lesser in comparison to the traditional method. This is the MSC, which in comparison is also reduced. This is the RMSE, root mean square error. So this is also reduced in our case. Now in the second scenario, when MLSC equalizer is being implemented at the receiver and after the demodulation, here you can see the coefficients has been given. So when I'm running this and doing the comparison, we are getting more better results in comparison to even WA based model, because MLSE is behaving as equalizing the output signal for reducing the more fluctuation among the received data. So the iterations that I have given to it are 30, so it will take some time to execute. So similarly, we have done the whole scenario for the fading channels, because here we are working on the AWG channel. AWG channel is basically the adaptive white Gaussian noise, which is also the because of the environmental, because but currently the systems are basically getting fade. So the relay fading, racial fading, and many fading methods are there. Those are also required to be considered. So we have evaluated the proposed methodology for relay fading channel also. Let's complete with these results and let we will see the outcomes those we can achieve from the another method. So it is running and let's see what we get. You can see the bit error is approximately 0 in terms of the proposed method. So here you can see in the terms of bit error rate, our ML and WA approach is getting much better results in comparison to the existing and even our proposed WA method without ML. So similarly for the MSC, similarly for the bit error rate. So these are the factors that we do have along with us. So I think this was for the RMSC. So this is for the AWGN. Now let's see how the relay fading is working. So we just need to go to the relay fading, copy the path, go to the MATLAB, paste the path, press enter. Here both different files, one for normal WA relay based our proposed method, WML based relay fading. So when I'm running this code, so as I'm running this, you can see the whole scenario is similar, only the difference that we made into it is like the channel that we are using here is the relay fading one instead of the AWGN channel which was initially implemented. So we are seeing the impact of the fading channel. The whole scenario will work for the relay fading. In the relay fading, it is taking a bit more time in comparison to the AWGN one, because the module of the relay is taking more time to calculate the outcomes. So let's see what outcomes we get with the proposed WA in the relay for the filtration, and later on we will see the impact of WA and MLSE equalizer at the receiver and with the relay. So in this scenario also we are getting better results in the case of WML, because equalizer is an important phase in any of the communication, because it equalizes the signal and gives the better result. So the only difference in the AWGN and this scenario is the channel and the fading event. In that only AWGN is used. Here along with the AWGN, relay fading channel is also there. So in order to do the comparison, what we did when we are doing the simulation, we are saving the outcomes. So here you can see in the last, we just save the outcome in the terms of O underscore WA. So here you can see This is already simulated outcomes of the WA relay, which we will use in the second scenario to compare. So in the second scenario where WML is implemented, we have loaded those results which are came out from this simulation, and then did the comparison in order to show the compare that which is performing better in terms of the various factors like RMSE, MSC, BER. So 18 of the iterations has been done out of 30. So it is still running. So let it be complete. So the objective function that we are using is basically here is the function that is the objective function. So I'll also show you that what we have done in the objective function once this simulation is complete. In the objective function, basically we are checking when we are applying the filtration on the signal, then what exactly the MSC we received after applying the filter with respect to the transmitted data. So the coefficients with the least MSC are chosen to be the best hyperparameters for the filters which are applied to the system in order to reduce the error among the sent data and the received data, which is the main objective of any of the wireless or a normal communication system. So these systems can be implemented in the real world along with the industrial applications. Even the researchers can also do the further modifications into it and can use the strategy for further improvement. Further improvements are still possible into it. So for those details you can contact us directly, and let's see with the results now. So you can see 29 30 of the iterations has been done, and we are achieving the results in terms of the parameters. So the proposed method where FBMC was a traditional, and this is FBMC WA of the relay fading channel. So these are the parameters that we have achieved, and the results has been saved to us in the WO underscore WA. So in the second scenario, when I'm running this, you can see we are doing the comparison here with the relay WA. So let's see what results we get. In the meantime, let's see the cost function. In the cost function, the whole system is implemented, and every time the filter parameters has been applied and evaluated in terms of MSC and SIM-BER bitter rate. So these are the factors that we are returning from this function, and those are behaving as a fitness function. So this is should be the least. So the system with the least outcomes has been used here in order to get the better outcomes. So the iterations are processing. So let's wait for the results to be there and to show that our WA and MLSC equalization based method is better in both of the scenarios of either only AWGN channel communication or AWGN and relay fading channel based system. So it can be implemented to the latest communication system like 4Gs, 5G, LTE systems in order to get the better signal at the receiver end. So let's wait the simulation to get completed. Then we will talk about the results that we will achieve from the current simulation. It is not mandatory to run for that much of iterations. We just carried out the simulation for the 30 iterations. It can be less or it can be more. The only objective is to get the better results. So because we kept it similar in all the 4 files, so that is why we are running it for 30 iterations in order to get the comparison among the outcomes, so that it can easily be justified and defendable. So in 18 of the iterations has been done. So you can see there is a variation among the outcome, which was started from 0.31688, then now currently it is 0.31531. So you can choose the iteration count as per the results you are achieving. As you can see, if we are going to run it for 15 iteration, after 15 iteration it is continuously giving the static results, because the optimization algorithms get static after a certain point when they are not getting any optimum outcome. So you can finalize the number of the iteration to execute on this behalf also after the number of simulations you conduct. So For the further even phases, you can reduce the iteration count because it is achieving around the static results around 15 of the iterations, but you can decide it only after this number of simulations, that in how many iterations you will be able to get the better results. So currently we are running for 30, so 27 of out of 30 has been done, and we will see the comparison among the outcomes. So the 30 of the iterations has been completed. Now let's see the results. As I already told, the parameters that we are considering are BER, MSC, RMSC. So let's see what we get, whether we get the improved outcomes or not. So here are the results. So here you can see the results are in terms of the different parameters. These are the proposed outcome individually. These are the comparison. Again, this is the individual. This is the comparison. This is the individual. This is initially the bit error rate. So bit error rate with the normal method was higher than FBMC WA of our proposed is there. Then the bit error rate of our proposed WA MLSE equalization is better. Similarly, for the MSC, that should also be the least. So our one is least in both the scenarios in comparison to existing one. Similarly, for the root mean square error. So further modifications are still possible into it for the communication domain. So stay tuned to our channel to get the updates. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.